Welcome to aminacademy.com. Now let us discuss about mathematical formula for vector algebra. First, we will define the scalar quantity. The physical quantities which are specified with the magnitude or size alone are scalar quantities. For example, length. So, length of a piece of wood, speed, work, mass, density, these are scalar quantities. What is vector quantities? Vector quantities refer to the physical quantities characterized by the presence of both magnitude as well as direction. For example, displacement of the body, force, torque, momentum, acceleration, velocity, etc. Now, vector notation. Vector notation is a popular notation in mathematics and physics for representing vectors which might by Euclidean vectors or more broadly members of vector space. Standard typographic approach for showing the vector is lowercase upright boldface front, that is V, that is thick letter V. The International Organization for Standardization ISO suggests using a bold italics letter V for the vectors. For a non-bold italic serif with the right arrow emphasis the scalar. Here this is a vector representation, that is AB or vector A with arrows. What are the fundamentals of vectors? A vector is an object that has both magnitude and direction. We know that. Geometrically, we can picture a vector as a directed line sequence. This, that is vector A, vector B, and like whose length is the magnitude of the vector and with an arrow indicating the direction. That is, the direction of the vector is from in tail to its head. From here, this tail to head is a vector symbol. Now, equality of vectors. When two vectors are equal, two or more vectors are equal if they have the same magnitude and direction. Like this here, vector A, this vector B, both are equality of vectors because having same size with same direction. But here, these are unequal vectors because the direction of C vector and direction of D vector is different. Two or more vectors are equal if they have the same magnitude and direction and they represent the same physical quantities. This means that they have the same length and point in the same direction, even if they are in different places, but it is equal vectors, but they are here not equal vectors. Multiplication of vectors by scalar. A scalar multiplication is the basic operation in linear algebra that involves multiplying a vector by a scalar or a constant. The result is a vector quantity with the same direction as the original vector but the different magnitude. The size changes. The scalar changes the scale of the vector. Next is sum of the vectors. How to add two vectors. Vectors addition is the operation in which two vectors are added to get their sum. Suppose we take two vectors A and B, then that can be added together using vector addition and the result vector is like, look at here, for example, this is vector A. This vector B. Then addition is like this vector A plus vector B. Now, what is vector subtraction? Vector subtraction of two vectors A and B is represented by A minus B. And it is nothing but the adding the negative of vector B to the vector A. That means A minus B is A plus of minus B. This subtraction of vectors involves the addition of vectors and the negative of that vectors. The result of vector subtraction is again a vector. Suppose here this vector A this vector B, then we can say this is vector A minus vector B. Look at here, this vector A is direction like and this is in opposite direction. So it is vector A minus B. Next one, unit vectors. A unit vector is a vector that has the magnitude equal to 1 unit. The unit vector are denoted by the cape symbol like. The length of unit vector is 1. Unit vector are generally used to denote the direction of vectors. A unit vector has the same direction as the given vector but has a magnitude of 1 unit. For vector A, the unit vector is unit vector can be represented like unit vector, that is cape vector, that equal unit vector is equal to vector A divided by the modulus of that vector A. Unit vector is equivalent to vector A divided by the modulus of that vector. Next one. Now let us discuss about laws of vector algebra. Here, look at some law. Here, commutative law. This vector A, we can give this arrow for vector A. Vector B can be written as vector B plus vector A. This is called commutative law of addition of vectors. Next, associative law for addition. Suppose consider three vectors, vector A plus then added together vector B plus vector C, which can be written as vector A added vector B, then its sum is added with vector C. This is associative law for addition of vectors. That is vector A plus vector B plus vector C, that is equal to vector A plus vector B, then added with vector C. Next one, associative law for scalar multiplication. Suppose take M is a scalar quantity and N is another scalar, then with multiplied with vector A, which can be written as scalar is multiplied together with vector A. Then which can be further equal N is first, M vector A also possible. That means Mn and N are constants. M is multiplied with N vector A is equal Mn vector A, that's further equal N into M into vector A. Distributive law. Then distributive law, look at here, suppose M added N, both are scalars which are multiplied with vector A is represented by M into vector A plus N into vector A. That is M and M plus N also is distributed as M vector A plus N vector A. Similarly, another with two different vectors. M is a scalar, vector A plus vector B is equal M vector A plus M vector B. That is M is distributed for addition of two vectors, vector A that plus vector B. Next one, what is component of vectors? The component of vectors are the part of the vector that represent each axis of coordinate system. In a two-dimensional coordinate system, the component of a vector are usually x components and y components. That is, horizontal is x components, y is a vertical components. In a three-dimensional coordinate system, the component of vectors are x components, y components, and z components. What is x component? The distance the vector travels along the x-axis, horizontal axis. The component x component is the cosine of the angle that vector makes with the horizontal. That is x component, that is vector ax equal vector a into cos theta. The distance of the vector travels along y-axis, that is y component. The y component is the sine of the angle of the vector makes with the horizontal. That is vector a with y component equal y direction is vector sine theta. This horizontal component is the a vector cos theta, vertical component is the a vector sine theta. So far we discussed about the basic vector algebra of and its formulas. We have done. Please subscribe our YouTube channel.